Hello and welcome to this video about special right triangles. The learning target for this video is to learn Pythagorean theorem shortcuts for special right triangles. Now, we have two types of special right triangles, okay? We have a 30, 60, 90. And what that refers to are the angle measures. So, you have a right angle, you have a 60-degree angle, and you have a 30-degree angle. And so that's your 30, 60, 90 right triangle. The other kind of right triangle we have is a 45, 45, 90 right triangle. And that looks roughly like this. And so you have 45 degrees here, 45 degrees there, and then you have your 90-degree angle. And so keep in mind that the 45, 45, 90, it is an isosceles triangle because you have two congruent angles and you're going to have two congruent sides. So it's isosceles. Now, all of this hinges off the Pythagorean theorem. A squared plus b squared is equal to c squared. And ultimately, what special right triangles are, they're shortcuts. There are ways that we can avoid having to crunch all the numbers, do the a squared, b squared, and c squared, if we have a certain kind of triangle. All right? And so what I'm going to do is first kind of show you how it works, sort of like the pieces of it, and then we'll go through an easy, medium, and a hard example for each kind. So let's start off with our 30, 60, 90 right triangle. So it all hinges off of the smallest leg, which would be next to the 60-degree angle. That one is x. So if we know what that one is, we're able to then say what the rest are. And so the hypotenuse is going to be twice that. And then the other leg, the taller or the longer leg, is going to be, this is where it's a little confusing, x square root 3. All right? And then with the 45, 45, 90 right triangle, the form is both of the legs are the same, so it's x. And what ends up happening is that the hypotenuse is going to be x square root 2. Okay? So what I'm going to do, I'm going to take these guys, I'm going to put them over here so we can see them. And then let's do some examples. So let's start off with our 30, 60, 90. Now, I'm going to kind of orient them different ways just to show that there are different looks to it, but the mechanics and the procedure is still the same. So we have a 30, 60, 90, and right here, we're told that this is 4. Now, another thing that's great about these special right triangles is you don't need two sides to find the third side. You just need one, and you can find the rest. So since this is 4, our hypotenuse is going to be 8, and then the other side, the longer side, is going to be 4 root 3. And that's it. Those are our answers. We're done. With the 45, 45, 90 right triangle, let's say it looks like this. So here we have our 45-degree angles. There's our right angle. And one of our legs is 5. Well, we know that the other leg will have to be 5 because it's an isosceles triangle, so they're going to match. And then the hypotenuse is simply 5 square root 2. And there we go. So again, super easy. I didn't have to do a squared plus b squared equals c squared. I'm following this format, this template for what the other side lengths ought to be. Now, let's kick it up a notch. Let's make it a little more difficult. So let's say that for our 30, 60, 90 right triangle, that we're given this as 4. Okay, that's fine. I just have to know that this part is going to be twice as big as my shorter leg, as my shorter leg. So the hypotenuse is twice the size of the shorter leg, so that means that this is going to become 2. And once I have what this is, I can figure out what the other leg is, which is 2 square root 3. So that one, we kind of had to adjust a little bit, and we had to analyze this relationship here to see how, if we want to go from the hypotenuse down to the shorter leg, we have to cut that in half. So that's what made that like a medium level problem. All right, now let's take a look at this. And now what I'm going to do for this one is I'm going to make my side length 5 square root 2. Well, the other one has to match, so that's also going to be 5 square root 2. Then for the hypotenuse, it's going to be 5 square root 2 times the square root 2. Now here's the thing. Root 2 times root 2 is going to be just 2. So that's going to be 5 times 2, which is 10. And so that's what makes it a medium level problem, is that we have to multiply out those square roots, which become a whole number, and then we'd have to simplify a little bit. So we just can't simply say it's 5 root 2 root 2. That has to be reduced and shortened up a little bit. Excuse me. All right, now let's take a look at the hard problem. So let me clean this up. All right, cool. So now for the hard problems, let's say that we're given this side. Now this is where it gets tricky, okay? So when we have the long side and we need to get to the short side, I'm just going to kind of show you the method you use for it later, or like why it works is a completely different video. But what you want to do is you're going to take whatever this side is, so we're going to call that x, times it by root 3, and we're going to divide it by 3. And so that's what's going to go over here. So in this case, we'll have 4 root 3 over 3. Okay, because what happens is if we took this, if we took this guy and we times it by root 3, it would actually cancel out all those 3's in there and then give us back to 4. Now, once we have the short leg, the hypotenuse is much easier to get. Just double that number right there. So 8 root 3 over 3. Now this one's a little bit trickier. It's going to take a little more work to understand. So let's do another example because this one can get a little more complicated as well. So, oops, let me undo that and just get the 4. There we go. All right, now let's say we have something like 9. All right, well, what I'm going to do is I'm going to have 9 root 3 over 3. Now, I got to be careful with this because this guy can be reduced a little bit. So that's going to give me 3 root 3. And that's the actual side length for my shorter leg. My hypotenuse needs to be doubled to be 6 square root 3. And there we go. We have our 2 lengths. Okay, now that's the hard level problem for a 30, 60, 90. Let's look at a hard problem for the 45, 45, 90. Okay, so for the 45, 45, 90, let's say that we are given a whole number right here. Now, again, the legs have to be the same because it's an isosceles triangle. So in order to figure out what that's going to be, again, we're going to kind of have a similar method to go from hypotenuse to the legs. And what that's going to be is x root 2 over 2. And so here, this one is simply 5 root 2 over 2, 5 root 2 over 2. And there we go. That's it. Now, yeah, let's do another example because it's a little bit tricky. And again, how and why all this works is a topic for another video. But let's say we had 12. And so what's going to happen is it's going to be 12 root 2 over 2. Well, these guys can be reduced. That'll be 6 root 2. And then this guy becomes 6 root 2 as well. And now we found our 2 missing side lengths. So just to recap, special right triangles, there are 2 kinds. We have our 30, 60, 90, our 45, 45, 90. Now, if you want to, you could always find the side lengths by just using the Pythagorean theorem. But with special right triangles, if we have one of the 3 side lengths, we can find the other 2. And we can avoid having to do a lot of arithmetic unless we're given a hard problem like in these latter examples. So that's what special right triangles do for us. Good luck with your homework or practice, and let me know if you have any questions.